All right, so we've done some work in class so far on reviewing for the Chapter 10 final exam. And we talked about things like direct variation in question number 1. Both of these equations are versions of what we call direct variation. They're written in different forms, but it's the same equation. One of them solved for y, one of them solved for k. And then the inverse variation has the same type of thing, two different forms of the same equation. One of them solved for y, one of them solved for k. We typically think of direct variation being multiplication and inverse variation being division. Of course, that's where things get confusing. When you solve for k, they look kind of backwards, but that's still the same equations. So on number 1, we made a table, and we added 2 columns to our table. And the first one being y divided by x. That's solved for k in this one, the direct variation. So if this column ends up being the same number, then we know that that's the k value. If this column, which goes with this one, is the same number, then we know it's inverse, and then that's the k value. Clearly, the inverse one didn't work out. You know, we got 2 values in and saw that they weren't the same number. But over here, we had the same number, 0.5 all the way through, so that's the k value. And then, so that made our decision, direct variation. So it was either going to be y equals 0.5x or y equals 0.5 over x. Of course, this one is wrong because it's inverse. So this is the direct variation equation with the correct k value. Question 2 tells me that they're inverse right away, so I expect you to write this down just so that you don't get the wrong equation. Now, you got to find k using the information given. Well, what did they give me? They gave me a coordinate, 1, 4, right? X equals 1, y equals 4. That information is given to me to find k. So we plugged it in, right? Plugged in our 1 for x and our 4 for y. Now, we are going to do multiplication is what we're doing. 1 times 4. Now, is that changing anything? No, it's still 4. But we are doing multiplication. If that was a 2 and 4, we would obviously say that k was 8, but that's not the case in this. But we still would do multiplication. I know it didn't really do anything in this particular case. So now we know that the actual equation is y equals 4 over x, right? 4 goes on the top, x goes on the bottom. Now, if you come down here to the last part, you could see find y when x is 20. Well, it's literally 4 divided by 20. Now, you could reduce that to 2 over 10, 1 over 5, or just write it as a decimal point 2. I don't care which one you do. Okay, but they go together. So once you have the model, it's kind of easy to do that one too. Hold on a sec. Okay, I have no idea where I was. I got interrupted by a student, but okay, I remember. So on the graphing part, it's clearly not a line, so those are bad choices. It's got to be one of these curved shapes. Obviously, they're only drawing quadrant 1, but now you've got to pay attention to the scale. The scale of each of these blocks is worth 2. So that's the point 2, that I've identified. This is the point 2, So the question is, when you plug in 2, what do you get out? So if you plug in a 2 up here, 4 divided by 2, clearly you get 2 for a y value, so that's why this one is the choice. Question 3 here, it's direct variation. I would immediately want you to make the conclusion that you're dealing with y equals k times x. And therefore, they gave me the coordinate. They gave me this coordinate in order to find k. So I should use it. You can see over here that we did. We plugged in the x and the y, and we divided to find the k value was 9 over 8. So what are we going to do with that? We got our 9 over 8. Now we get a new x value. So if x equals 16, what's y? That's the question. Well, so I go over here to my equation, I plug in 16 for x, and I calculate and get 18 for y. So that's my answer, 18. Question 4. We've got inverse variation, so immediately I write y equals k over x. They gave me this coordinate, so I could find k. So I plugged it in. Of course, we did multiplication to get there, 25. Now, some people like to write it over 1 and then say that you're cross-multiplying, which is not a bad suggestion. I like it. It still gets you the same thing, k equals 25. Now they give me new information. If I've got a y value of 5, what's x? So I wrote that down. If you've got a y value of 5, what's x? So we put in a y value of 5, put in our 25 over x, and cross-multiply to get 5. Okay? So that's what they were looking for. Okay, so that's page 1. Now, I jumped over to page 3. As you can see, I numbered the pages, like there's 2, here's 3. And this is for the chapter 10 section. Okay? Now, on this particular question, you're either going to have a graph that looks like this, using quadrants 1 and 3, or quadrant 2 and 4. Now, you can see that we circle quadrant 2 and 4, and that's because you have a negative k value. So this one, obviously, over here would be a positive k value. All right? Positive k value would look like this one right here. And we said over and over and over again all year long that when you make a change on the x, it goes against your common sense. So x plus 4 really means left 4. And the minus 3 on the outside here is the y value change, and we always said that that went with your common sense, so that's down 3. So the one that has the right shape can't be A or C. They have the wrong shape. So it's down to B and D. And the one that has the correct left and down would be this one over here. X equals negative 4, y equals negative 3. Okay? Asymptotes are untouchable. Remember, we have these asymptotes here at x equals negative 4 and y equals negative 3. The branches do not touch those at all. They get closer and closer, but never touch. So what about domain and range? Well, if these are untouchable, then those would be the only exceptions to the domain and range. So if you know the asymptotes, then you know the exceptions for the domain and range. Everything except negative 4 for x, everything except negative 3 for y. Now, over here on page 4, we're starting to get into the factoring, all the factoring stuff. Look for things like greatest common factors. Here in the denominator, we can see that there's a 5x, that both of them have a 5x. And so when you divide out a 5x, up here at the top, I actually show the division. You're taking each one of those things in the bottom and dividing by 5x. And what you have left is 5x minus 1 on the bottom. Well, look what cancels out. 5x in the top and the 5x in the bottom. So we know what's on the bottom, 5x minus 1. Remember that whenever you get rid of all the factors, there's still a 1 there. So you can put that 1 up there. And that's your final answer. Remember, we don't do anything with the restrictions, so you don't have to worry about that for this either. On question 2, when we're doing multiplication, you'll see that I just drew this kind of, separated things out. And then you can see that I did my work over here. So the first thing I want you to do is factor everything. After we get done factoring, then we'll reduce. Okay, so let's take a look at what the factoring is. I do see a GCF right here. This one, 2x plus 14. We can pull a 2 out. When we pull a 2 out, we get x plus 7 left inside. The x plus 9 in the bottom there, can't do nothing with that, so that has to be left alone. Over here, remember, when you're factoring trinomials, there's no GCF to worry about in this case, but they need to multiply together to give me 24 and add up to 5. Okay, that obviously means one's a plus and one's a minus. So I wrote over here the factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now the reason I write them in a V-shaped pattern is so that you understand that as they get closer together, as they're coming closer and closer together, when I get real close together, I run out of options. There's no more options. Okay, so out of those choices, 8 and 3 is the one I wanted. Now, obviously, one's positive, one's negative. That's the only way you're going to get them to add up to 5. And they also have to obviously multiply to negative numbers, so that means they have to be 1 plus 1 minus. Out of 21, your choices are 1 and 21, or 3 and 7. This is the only combo that has a difference of 4, so that's how you get the 4 in the middle. So that's x plus 7, x minus 3. After we've done all the factoring, then it's time to reduce. So we can see with the x minus 3's disappear, the x plus 7's disappear, and that leaves me 2 times x plus 8 on the top and x plus 9 on the bottom. I don't care if you leave your answer like this, or if you really feel like you have to distribute the 2, be my guest, it's not going to hurt my feelings one bit. Okay, either way is good. Okay, next page. Page 5. So, once again, this is a multiplication question. We're going to factor and reduce. So, we factored. Now look here, we've got we don't have any GCFs anywhere, but we got all kinds of trinomials to factor. In fact, this one down here is a difference of perfect squares. That's x minus 2, x plus 2, because they have to add up to 0. So I didn't write out the factors on this one, factors of 12, factors of 2, factors of 6. I just did the factoring really quickly because we were in class and we were doing this one real fast, just to make sure we knew how to do it. So I wrote out all the factors, and then I looked for what canceled. You got rid of an x minus 6, you got rid of an x minus 2, you got rid of an x plus 2, and you got rid of an x plus 1. So once again, you got rid of all the factors on the top and all the factors at the bottom. There's still a 1 on top and a 1 on the bottom, which makes the answer 1. When we get to division, division is the one where we're going to factor it and then change it to multiplication. So when we factor it, hold on. So on this question right here of division, sorry to get interrupted again, but we factor everything. So I see a GCF right there. A GCF in this case was equal to 5. We can pull that out. That left us 5 times x plus 7 there. Then after we've got everything factored, we change it to multiplication. Remember that whole keep, change, flip. So we keep the first fraction, change to multiplication, and flip the second one. Then we look for reducing. In this case, the x plus 7s cancel out. We only have a 2 left on the top. We have 7 times 5 left on the bottom, which is the final answer of 2 over 35. More x's. Question 5 is another division question. No GCFs. I don't see anyone there, or there. No GCFs anywhere. Okay, so we could start the factoring process. Now over here, you can see that I kind of separated it into factors of 12, factors of 36, factors of 18, factors of 27. So, you know, that you could get the feeling of what you're going to have to select from. What would multiply together to give you this, but add up to this. So, I wrote out the factoring here. We have x plus 3, x plus 4, because that adds up to 7. And you notice that I accidentally switched everything to x's. It's okay. I don't care if you do y's or x's, whichever you're more comfortable with. I was in an x zone, and I just went ballistic with x's. Okay? Don't take that the wrong way. All right, so x plus 3, x plus 4. And then x plus 9, x plus 4 were you multiplying to 36, but adding up to 13. And then minus 6 minus 3, that adds up to negative 9. Plus 9, sorry, my plus 9 will become weird, wonky, maybe. And then 9 and minus 3, they add up to positive 6. Okay, so that's the factoring part. Then we get to the change to multiplication part, where the first fraction stays the same. Change to multiplication, flip the second one. Right, everything bottom to top, top to bottom. And then we reduce. You can see the x plus 4 is canceled out. You got an x plus 9 and an x plus 9. You got an x minus 3 and x minus 3. So the only thing left on the top was x plus 3, and the only thing left on the bottom was y minus 6. Obviously, if you were using y's, it's going to look like that. Like that. Once again, I'm not going to take off credit if you accidentally switch to x's. It's not a big deal. Okay? This is where we left off. I don't think we got further than this today while you were gone on your senior activities. And then we will finish reviewing on Monday and do our test on Tuesday.